I'm Ferki, and today I'd like to talk about Rex and some use cases and various patterns with it. And first, I would like to thank you for every participant, all the organizers, partners, speakers, and attendees to make this event possible. I find it very nice to have an in-person conference again with all the Perl and Koha folks. Also, happy CPAN Day. I think several years ago, I think maybe in 1995, August 16 was the first ever upload of a module to CPAN. So it's very nice that we have an event that coincides with that. In this talk, we will have a couple of sections. First, I would like to talk about some introduction to Rex in general. This is about what I find a good mindset to be in when we talk about or think about Rex. And then also we'll just give you some more like practical examples in the second part about a quick start with Rex. And I would like to finish with some inspiration for more advanced use cases. Between each sections, I will pause for questions if you need to need something clarified. So feel free to ask. But also, like during the talk, if something is like entirely unclear or I should change something, just let me know, please. So let's start with the actual topic. I know some of you in the room might be already familiar with Rex, but I would like to ask everyone, like, do you already use Rex or know what it is? Any of you? All right, a couple of people. All right, so that's good to have the introduction part for the rest of us. And what other software you heard or know about in configuration management topics and infrastructure automation? There are many in this field. I was just curious, like, what are you familiar with, perhaps? There were a couple of talks about Ansible. There will be a talk about Ansible after this as well. Any takes, experience with others, please?
Well, I have some experience, mostly with Ansible and with Puppet.
Yeah, Puppet. Yeah.
Salt, about CF Engine, about
CF Engine, right?
Another one I don't recall the name, but it's basically like Rex in Python. Oh, sorry, bit late. Yeah, SaltStack, Puppet, Chef, Capistrano, Terraform, CF Engine, and several others, and don't quite recall at this moment.
Yeah, thanks for this quick collection of this. Looks like you had a bit of an experience with many of them, and that's what I also collected. And on the screen, like, those are the most popular ones in my experience, and more often used or well known. So these are the topic we are going to talk with. Rex is also active in this space, basically. So if you are familiar with some of those tools, some of the concepts would be already familiar here as well. It's more like just like solving it in the Perl world and with our own trade-offs. Rex was originally started in 2010 to solve parallel deployment problems, which was not really possible back then, I believe, with Capistrano, what you also mentioned. So initially it was branded as a deployment management tool. And since many of the capabilities required to do so, such deployments can also be easily extended or reused for other things, it became a more generic configuration management tool. And as we got a lot more contributors and like features added, after a while we started to call it a framework for system administration and data center automation. But as you can feel, this is like getting very long and like more and more generic. So we decided to just rebrand it a little a couple of years ago, and we call it the friendly automation framework. And I would like to explain why we consider it the friendly one. And like, it's about automation, we already established that, and like why it is more like a framework than a tool. Those are the main values in Rex when we develop it, and also when we talk about it with others, especially during introductions. I think it's like very good to be aware of these main guidelines. And these are, it's just Perl easy to get on board, and puts you in charge. Let's talk about the is just Perl aspect first. I believe that is like one of the main strengths of the approach we take with Rex. And the basis of that is Rex code is just Perl code. And it's best to start with like considering how other tools approach their own solutions. And because most tools decide to create their own custom DSLs. And because of that, often common programming concepts such as loops and conditions become added later as an afterthought. And I heard this term about this phenomena, like they become accidental programming languages. If you were at the Ansible talk yesterday, or maybe we already had this discussion with some of you on the hallway track, a common expression we hear about, for example, when working with Ansible, is like it feels like programming in YAML. And the basis of that, or I think the root cause of that feeling, is more like using a data interchange format, that is YAML, to implement some logic. And that's where it might feel a bit like there might be a gap in the experience and expectation. Just to follow up on some of the examples from yesterday's talk from Stefan. For example, with Ansible, when you write YAML-based logic, that's how you could create a custom directory. You use the file module, you specify the path you want, and like what's the desired state, it's the directory. But if you want to extend it, you need to create multiple directories. You have to add more, like, and with items, that becomes a loop basically, and so it creates 3 directories. But you may want to do it only on Ubuntu, so you have to also add conditions and checks. So it can grow in this direction, other tools had similar paths during their development, in my experience. For example, if you're familiar with Terraform, there was a big change between version 0.11 and 0.12. They added a lot more features and revamped a lot of internals, so a lot of value was added. But what I found personally interesting is like they started to support loops and conditions. So it was like kind of, again, the same story like with other similar tools. Puppet also had this on journey into Ruby DSL and then back there to their Puppet DSL. So it looks like this is a common pattern when various automation efforts try to map the real world into their own custom DSLs. And then sooner or later, they probably like reach the limitations and then decide to just grow it to support these common use cases, especially as the community around it and the user base around it grows. So coming from that direction, and in contrast to that, I think that's why it's a great strength of Rex, that it is just Perl, because we are 100% compatible with Perl code, and Perl itself is already a battle-tested mature language, also includes loops and conditions out of the box. It's not an afterthought, but a first-class citizen. And it also allows us to build on top of the already existing vast ecosystem around it. So we can use the same editors, syntax highlighting, linting, testing, formatting, and also the publishing tools, authoring tools can be the same. So we do not have to invent it from scratch just for the purposes of Rex, but we can already reuse this vast ecosystem. I think, especially in a completely volunteer-driven project, that is a huge advantage. It also means that Rex is seamlessly extensible with your own custom code or even from CPAN. So whenever the built-in features end and you reach some limitations, it should not stop you, but like enable you to just continue with your own. And hopefully you might even consider contributing back if you have some nice solutions. And also through the power of CPAN, after all, it's not just Perl. There are modules on CPAN that allows you to use any other programming languages or most other programming languages. There's an inline family of modules I think there's like Python, C, Java, a lot of them are supported, but also like the FFI Platypus module. I think that's like more like Rust and Go support through a slightly different interface, this foreign function call interface. So I think that's why this is one of the main values of the approach we take with Rex. The second big topic here is like it should be easy to get on board, meaning Rex, I consider Rex instantly usable because it's already packaged in many popular operating systems like Debian, Ubuntu, Fedora, so on. I also package it for Gentoo, but that might still require, management access to the machine where you want to run it. But since it's just Perl code and it's published on cpan, you can just install it in your home directory, and whether you are on like a Windows, Mac, or Linux, you can use it. And it also only relies on SSH as an agent for remote management. That is like most probably already in your stack if you are dealing with remote management problems. Maybe not in all infrastructures for sure, but it's a very common one. And this easy to get started, easy to get on board idea is also important because you can start using it without big rollout processes, or maybe even convincing any other people on your team or on your management, just to get started with like automating your own work to be more efficient and like more precise with your own tasks. Actually, that's also how I started using Rex about 10, 11 years ago. I just wanted to, don't repeat myself by following the same script and same documentation. And when I discovered Rex, I just ported those steps I needed to do on a given day to Rex code. And the next day I could afford to just like run the same task again. And also it enabled me to share it with my teammates so they could also profit from it whenever they got curious, like how I can do it faster than they do. And this is what I mean by the last point. Like I consider Rex in a pretty ideal situation for incremental automation. You don't have to like solve all your problems and like all the infrastructure management in a pre-existing environment, but like you can start small and just like automate what you have to do today and add more later, essentially converting any Rex-based project into a standard software development project, right? So requirements change and then you follow up with them and implement what you need. And last but not least, we also have this value, or like in the philosophy around Rex, like it should put you in charge, meaning we recognize there are no silver bullets when it comes to infrastructure management. And because of that, Rex tries hard to don't force any specific model on you, and instead trust you to be in the best position to decide what you need to solve and how you want to solve it. So in that sense, it's just like a different trade-off, right? But in essence, it gives you the building blocks to build your own tool. So that is like underlying the framework nature of it. So there are no, so of course there are some built-ins that might help you with common tasks, but you can also override them anytime. But this is one of the best things about it for me, that I can just build whatever my situation needs instead of following a predefined pattern decided by others, right? So I don't have to fit my problems into the model, but I can find a solution for my problems. And the combination of all that is why we started to call Rex the friendly one, the friendly automation framework, because it doesn't really care too much about it. It's friendly to every possible use case we encountered so far. And especially if you're already active in the infrastructure or configuration management world, it might ring some bell, like various models, like push and pull style models or imperative and declarative models. Let me just explain this a bit. Like in a push model, you have a central place of management, and for example, over SSH, you connect to remotely managed endpoints and configure them and check the results. In a pool model, that is like more like, for example, Puppet follows a pool model. There's a central server, and the agents are running on all the remote endpoints, and periodically they check in, pull the configuration they need to apply locally, and check if they should do something or not. Rex itself doesn't care about this. You can implement both. And also like imperative versus declarative might be interesting here. Like by imperative, I mean like go to this endpoint, run this command, and do it. Meaning like, please create a directory. Versus the declarative is more like describing more like a resource. Like there should be a directory named this, and it should be a directory in the file system, not a file. So declaring the desired end state, and then the tool should go there and figure it out whether it's like already existing or not, or maybe it's a file already, but it should ensure and enforce this desired state. Also, usually providing idempotency, so you could run the same code again and again, and it should recognize whether it's like already at the desired state, and then may choose to do nothing or just report that, yeah, it's already like that. But if there are like some configuration drift, it should recognize that and correct it, and should enforce it back to the desired state. So Rex itself is friendly to all these different use cases and ideas. It has less opinions about them and provides these building blocks for you, so you can choose which one fits your problem. And as a bonus, it's all open source under Apache 2 license, and already mentioned, like we are completely volunteer driven. Over the past 13 years, I think we have like 120 plus contributors. So it's you are also welcome to join the party on our channels. So that was the first section about the introduction. Do you have any questions about the things so far that I should explain more?
Olli Kivilahti from Hypernova. The first question that popped up in my head is, how can you compete with all the modules Ansible has? That's a huge ecosystem and all the modules for everything, and you have to port this all to Perl.
Yes, that's a good question. And one answer to this is like, we don't. And there are multiple reasons for that. On one is like the community, I think, is still much smaller than the Ansible community. And that is partly because Ansible is a commercial project backed by Red Hat since 2015, I think. So they bought the code and the developers around it, right? So there was a company established already to support Ansible, and we are completely volunteer driven. So that puts us into a slightly different change. And that's why I also like encourage people using Rex to publish their code with the standard, or publish their solutions with the standard Perl approach. They do not have to learn anything new if they are already familiar with Perl. And also this framework nature, I think, is relevant here. This kind of approach, I think, largely encourages people to just think hard about their problems and then finding solutions quickly for them. So it enables them to go fast, but it is often a viable solution only for them, or at least that's how they perceive it. So I know about many commercial uses, but relative to that, I also see that like comparably not that many contributions coming back or getting published. It seems like changing in the past years. So there are more and more modules from third parties on cPen itself, or if you search around GitHub for Rex files, you can find solutions. But I think those are the main differences and like leading to this like, I don't know, call it imbalance maybe. But the background is largely different, and I think that's one of the effects on this.
My question is, what's the minimum Perl version needed, and does it which operating systems are supported?
Excellent question, thank you. It was not part of the introduction. It's explained in detail in your contribution guide, and there are two main things to differentiate between. One is for operating system supports, like where Rex is supposed to run, and also like what Rex is supposed to manage. It's not necessarily the same thing, right? So what we test on is Linux. So we have a GitHub Actions based testing. So we test every change on Ubuntu. So that's the Linux testing part, and on Mac and on Windows. So all the major platforms. And we also heavily rely on and say a lot of thank you for cpan testers. They also provide a lot of, especially more exotic systems through their testing, like Solaris, FreeBSD, Open, all the BSDs basically, not just FreeBSD, Sigwin, so it's like more like the less used ones, and also for what we have less means to support as a community, but we do get active feedback that yes, the test suite passes, so it should work. Managing things is a slightly different topic. So there are a lot of built-ins, mostly for Unix-based systems. So I would say all the larger operating systems are well supported, like Debian-based systems, including Ubuntu, or RPM Red Hat-based systems, including Fedora, used to be CentOS as well, and some of the flavors like Alma Linux, Rocky Linux, so that family. Also BSDs, and managing Windows is, I would say, that is the less developed part nowadays. That's just like, I'm not aware of anyone in the community working actively on that, but every new development is supposed to be able to locally manage Windows, which gives us a lot more confidence if whenever we have to walk the last mile and like maybe start supporting some remote management capabilities on Windows. So it's like contributions are welcome. There's even a GitHub issue about that, like help wanted. I personally don't use Windows, so I have less visibility into what might be missing, but I'm very happy to support anyone stepping up and needing this in production or for their use cases. And back to the Perl versions, we currently require Perl 5.12 as a minimum to run it. And we are actively testing on all these operating systems I mentioned earlier, all the minor releases since 5.12. So there's a quite big matrix to run, but it did prove useful, catching very weird bugs over the time. So we run it on every change, basically, to make sure we are not accidentally breaking even all their systems. Oh yeah, and Perl on the managed systems is not directly required, although if present, often Rex makes good use of it. So it tries to see if Perl would be available there and just tries to fall back to different methods if it is not available. So I wouldn't call it a hard dependency for many or even most use cases. And I think it's 5.8 is assumed, so like nothing fancy. Yep, I think that is all around this topic. All right, thanks for the question. All right, let's go forward. If there are no questions. The next part is more about the code itself, like how does it look like working with Rex, and how to get started even. I also try to include some live demo and actually run some of the examples. We'll see how that goes, but I think the main part, like the code itself and the commands you execute, is already there. I did have to convert some of my examples in the past days due to the limitations on this network, but I do have like locally running virtual machines now, so probably it should work well. So first of all, let's just do some ad hoc usage. That was also part of the talks yesterday, and this is like commonly used. We don't want to write some complicated code, but the same way as with Perl, it's possible to just like evaluate some ad hoc commands on the command line. You can do the same with Rex. So Rex is a script to run Rex-based solutions. If you don't want to exclusively use it as a library, for example, and it's a common way to interact with the code or with ad hoc use cases. So -E is for evaluation, and let's just say hello world. It should run locally, As also indicated by the first line, there was a task from the evaluation line, and it is running on local. And there's the output, hello world, as expected. And it also reports like all tasks were successful on all hosts. It was only a single host this time and a single task. So that is the general output and the workflow, but it's probably much more interesting if you start to writing it down. Pretty much the same way that with make, you have a make file. With rex, we have a rex file. I like that it's a bit less typing, but otherwise it's the same concept. And how does a rex file look like? First, it's usually like use rex, like with any other Perl module. And I highly recommend using descriptions for the tasks. So let's just go describe this task with like say hello, that's what it does. And then we define our first task. The task keyword is the first one there. We give it a name, let's call it hello. And then it is followed by an anonymous subroutine. So again, as you can see, complete Perl compatible syntax. This is the task definition itself. And then inside the subroutine, we can define all the task steps. In this case, it's just like saying hello world. And it actually has an exclamation mark now. And that's it. That's our first task. Let's try to run it. First, try to get a list of Rex tasks. And as you can see, I prepared a couple of more things that we can run during this talk. And hello is one of them here. And there's the description, say hello. And this is like minus uppercase T is like the task list, like give me the task list. If I try to run it with Rex hello, that again runs as expected. The logging lines are slightly different to note that it is coming from a task definition, not from the command line, but it is still running on the local host, outputting the expected hello world string, and then reporting the results. As I mentioned, I prepared a couple of virtual machines. One of them is called Helsinki, and I want to run the same task on a remote over SSH. For that, I should specify what the target is. That is on the command line, possible with the minus uppercase H, short for host. So this command should run the same hello task on the Helsinki host. Let's try to run it too. That's for password. All right. Maybe I should skip it. I don't want to do too much debugging, but that is what would run it on the remote. All those were like pretty simple use cases, like not really doing too many actions. But what are the really interesting ones are like the real core competencies of any configuration management system is basically these two: be able to run commands and manage files, and everything else is practically an abstraction on top. So that's what I would like to show how to do this with Rex. And that's where I also consider it's really important that it's just Perl code. Perl feels very ideal for both of these domains. So running a command, again, starts with the description, say hello from a host. Let's call it hello from, and run the hostname command with this line. And save the output in a scalar. Let's call it my $hostname. And then just say it, right? Use it in a string. So I can run it locally. And if you wish, I can still try some debugging for the remote examples. If you prefer that, that would have been really nice if it works out of the box. Or I can show it later to you if you want. So your choice, but I don't want to hold up too much of the time. Should I try to reset things or? All right, I try. I think it's just about my keys are stored in GPG, and I think something was garbled out there. So I try to run this. Now it's still. I can try to. Oh, okay. So I know the password. All right, so this is a bit of an unexpected part of the demo. Sorry about that. But as you can see, when the key-based authentication was not immediately possible, I tried to keep things simple and not bring password management into it. But with specific backend modules, it can prompt for it interactively. So to provide the fallback, it's also like possible to force it that like, please don't do that, just fail instead. But as you can see, the hello from task was running on the host named Helsinki now, and the output of the hostname command inside the host over SSH was Helsinki, so it retrieved it successfully and could use it in a string through saving it in a variable. And again, everything was successful. So we are looking for this like green signs along the way. All right. We are actually having 2 hosts defined on my machine because in most practical use cases, there are more than 1 machine to manage. I just try to keep it to the minimum of plurals to have multiple machines. Like I define 2, so there's Helsinki, a Helsinki 2. And with the group keyword, I can define a group of hosts. And let's call it demo hosts in this example. And that allows me to run the same tasks on multiple endpoints. I will probably have multiple password prompts, so I will try to be fast in typing it. Yeah, that's one, that was the first host, and now it's the second host. So what we could see, it went through the list of hosts as defined, one by one, and executed the same task, and it could retrieve the different host names and like allowed me to do something useful with it, in this case just print it. Where it got more interesting is what I mentioned in the introduction, what one of the original reasons to start developing Rex was like a parallel deployment capabilities. So now we have 2 hosts. It might be interesting to try to do it in parallel on 2 hosts, like execute the same task. With that, we have this -t, lowercase t, that's like short for threads. And I have 2 hosts, so I try to run it with a thread count of 2. So you can see the tasks are already executed on both, but still waiting for the first one for the password prompt. So that was 1. And yes, this is the test password. That is common in the Rexword for testing, because some built-in features could rely on that and change upon provisioning. So I just use a standard Rex testing VM here. All right, but something might be garbled up, so let's not wait for the other one. But the same idea is available with a slightly different thread count called max. Sometimes I cannot know in advance how many machines are there. I just want to do it as fast as possible. So if I have groups with 10 members, the thread count should be 10 for the maximum speed, while with other groups, the group count might be just 3, so it could be dynamically adapted with -t max. Otherwise, it works the same as specifying 2. So that was about running commands, and the other core capability is like managing a file. So for that, what I wish to prepare and show you is something like time-based, just to prove that like it is running right now. So for that, I first import timepiece, that's part of core, to interact with timestamps and dates in a convenient way. And again, this is, I think, a good demonstration that you can just use any CPAM module or like whatever is part of core, just import it as usual. Again, we have a task description. Let's manage this file example. Let's call it this task manage file. And by default, I specify it should run on the host Helsinki. This is a way to enforce default targets for tasks. It could also be a group or a host or a list of hosts. This feature is most useful in very specific use cases, like for example, inside my own organizations. But I personally find it better to leave things open for modules and tasks that are supposed to be used by others, like especially published open source, right? Because then you can specify and also must specify where to run. But it is possible that it is a task that must run on the Helsinki host and nowhere else. That is the intent of the author. There is a way for that. So that is the default target now. First, I just specify which file I want to write to, and I retrieve the current timestamp. And this is the file management command inside Rex. So this is the declarative style and also idempotent. I describe it basically as a resource. It's a file type resource named /temp/example. That is the full path to the file I desire to create. And then I can specify my content and just use the timestamp there and say hello Helsinki. So this is the content of the file after it is created. It is possible to add more options to the file command, like enforce permissions, ownership, and so on. Not just the content. But as a last step here, I would like to just show get the output to prove that we wrote something into it. So let's try to run it locally first. Oh no, it's on Helsinki, right? Because that's the default target. So we can connect there, and as you can see, the timestamp is like right now. So this file was created right now and was actually written on the remote host. But I can also do that same with the local host by using again the same override mechanism on the command line. And since the default host for this task is currently a remote, the machine called Helsinki, if I want to override for local execution, I have two choices. One is to connect to my local host over SSH. I can do that. Or specify this otherwise invalid special placeholder called local. As you could see in the first example, it's like that's what Rex internally uses to represent local execution. So let's try to create the file on my machine too. Yeah, that also worked. And it did not ask for password. That's good. So it was a local execution, not over SSH. Running it on a group of hosts is a matter of the similar approach, but instead of -h, just -g for group. I can try to run it, but it might also fail somehow on the password prompts. Oh no, okay, no, it prompts for both. As you can see, it is running on both hosts and like always writing the current timestamp at the time of execution on that host, right? What I think is relevant here is to stop for an extra thought about the file resource and introduce the on-change hooks. Because what we did is like create a file, write a specific content into it, and then just like read back that content. That means we are using, since we are using a timestamp-based content, it will change on every execution. So it gives us a nice opportunity to just use an on-change hook for the file resource and specify yet another code reference to do the same. Like, please run this command, cat $file, and say the output. So it will only run whenever there's a change on the file. With the current approach, it would change with every execution. Maybe if you can execute faster than a second, it would stay the same, but otherwise it would be executed. This is very handy, for example, to reload some applications whenever the configuration file changes, and we will go to such an example later. One of my main examples where it all comes together is about like configuring something that is more useful than just like reporting the host name and like creating a file. And for that, I chose a software package called Crony. It's similar to NTP if you're not familiar with it. It's about like synchronizing time and keeping the proper time on servers. And I chose it because on one hand, it's very simple to manage and install. It's just one package to install, one file to configure, and one service to run. And those are the main steps of any like software lifecycle management, right? The fourth one could be like decommissioning, where we stop and deinstall it. But let's just focus on the first three for now. It also good example, I think, for this because it's quite different than any of the Perl stuff we usually talk about at this conference. So I think that helps with like keeping a fresh mind. So for installing packages, we would need to escalate our privileges and use sudo or connect with root. That's also possible. And if we use sudo for our commands, we also should specify what's the sudo password. Because most of the time, sudo interactively prompts for it, like you should enter your sudo password to gain your extra privileges to install packages. And in case there's no sudo password, like on my VMs, it can be left empty, but it has to be specified like, yes, this is intentional, right? So that's about the setup part. Then we can create our task as usual. Get a description, name it crony. And the first one on a Debian or Ubuntu-based machine, it would be a run command and call apt-get install crony to install the package. Then we could install a file. No, we are not writing content directly, but like use a source file. Like, please copy this file over there or make sure that these two files are the same. That's about the configuration. And then we should start the crony service to get it running. So those are the three main steps of the life cycle. Although there are a lot of possible bugs with this approach. Can you spot some of them? What could be the risks with this, like, let's say, direct approach using the run commands? Apt-get would fail, yes, or prompt, right? That's pretty close to that. Let's go through these risks and how Rex can manage that. So first, what I collected is like error handling. So like you said, it could fail. So we should check for the return code, whether it's like success or not. And if not, we probably want to throw an exception with die. And we would have to do that for all run commands. That wouldn't scale too much. So what we can do is check the Rex documentation and check for die. And as you can see, there is a feature flag, exec auto die. Let's check what it does. And it says, like, if you execute the command with run, Rex will automatically die if the command returns a non-success, right? That sounds like exactly what we want. So what we can do is, instead of use Rex, just enable this feature flag. That helps us with error checking, and it will stop execution at the first problem. It is very similar to bash set error exit, right, or set -e. The next one is like unattended installation. It's often not as easy as one may think at first. So this form, apt-get install crony, might ask for human input. You have to press yes, that I do want to install it. So we should actually add the extra command line option, -yes, assume yes. But actually we have to add one more, because that might still prompt depending on the underlying dpkg configuration. Even then, we have to add several environment variables to make it really unattended. First, check the listbox frontend and the list changes frontend and the Debian frontend non-internet. So isn't there a better way to do that? So let's check the documentation again. We want to deal with packages. We can see that there are built-in functionality about managing packages, Rex commands pkg. So let's go to there. And what we can see, we can specify the pkg keyword, name of the package, and ensure it's present or it's on our latest version and so on. So let's try to use that instead, meaning all that previous boilerplate becomes just this. The next one, we forget to sync the package definition first. So if it's like a fresh machine, there might be no package definitions yet. We have to run apt-get update. Or if it was synced a long time ago, again, we might get outdated packages. But the same problem is there. We should expect human inputs and like try to suppress them in an automated way. So we, again, don't want to repeat it. There's a built-in function for that, update package db. And as you can see, the name of these functions are like really independent from the machines. So Rex when starts to manage an endpoint, tries to figure it out what type of system it is. And if it's a Debian one, it tries to use apt. If it's a Fedora one, it tries to use yum or Gentoo emerge and so on. So that is, I think, where a lot of value comes from the Rex abstractions. Again, around the services, we can do the same, not just start the service, but we want to run it on boot. When we reboot the machine, we still want it running because the time synchronization is important. So we can check the commands again, and we would find the Rex command service module, which explains we can use a very similar construct: service, keyword, name of the service, and specify the state we want. Like ensure started means it should start it now, and you should start it on reboot. And again, under the hood, it figures it out. What's the service management system on the managed endpoint? Whether it's like system control or initv or OpenRC, it can use all that and abstracts it away from you. That allows us to convert the previous task, let's call that like more like a naive approach with direct run commands, to the built-in features. So that is using, let's say, the Rex way of doing things, using the built-in abstractions to do to create portable tasks, and it would be able to run on many different operating systems or even locally, not just over SSH. What we missed in this example is like we are using a file, so that is the file content. It's just like, please use the Finnish pool of NTP servers. It's the same configuration for Crony as for NTP. And I can try to run it on Helsinki. Oh, it's not prompting now. All right, that's different. Let's just cancel it and try to run it again. No prompt now. All right. So I was not entirely successful with converting my examples to the virtual machine yet. Sorry about that. But it would do all the steps as specified. Sync the package definitions, and then install the package, deploy the file, and then start the service. What we can do at this point, and since it's just Perl, is to try to split this big task up into smaller phases. Like first one is about Crony setup, so package installation goes there. Second could be Crony configure, to just ensure the configuration, and then we manage the service, and maybe we can even add the check command, like please return the status of this service as a last step. As you can see, the prefix is always Crony underscore. That kind of hints me that it should go into a module on its own and use just a namespace for it. So we can create a Rex demo Crony package in the usual Perl ways. So we define this namespace and import Rex first with the -base feature. That's a more limited set of imports that is ideal for module development. But otherwise the tasks are the same minus the prefixes. It might get a little wrong. No, it fits on the screen exactly. Nice. So once I have this module, I can go back to my Rex file and just require it as a module, right? So all the tasks from the module would become part of the solution that is imported by the Rex file. So you might at this point start developing various modules for your use cases. Like you might need to manage Nginx or Apache for web servers, or Postgres MySQL for databases. You could have your own separated namespaces for that, and through the Rex demo Crony namespace, the middle part, the demo, could signify that yes, this is a local solution, like this is only for my company, for example, or for my organization. And preparing for open sourcing it, just in case, could be as simple as removing this middle part from the namespace. Yes, please.
Why do you require the module and not use it?
You can also use it, but there's like nothing really exported, so require is enough. That's the minimum code that is needed.
there's no special magic happening on use that you want to avoid. It's just you can use both of them.
No, Rex parses the whole configuration based on the Rex file and then makes sure that everything ends up at the right namespace. So there's nothing else to do on the Perl side there. And again, I mentioned the onChange hook before. We could just like specify that whenever this file changes, please restart the service. So then again, normally it would do nothing whenever I run it, but whenever I want to specify new service, it will just restart the service. At this point, this is how I would run the whole setup, which gets a bit long, as you can see, but it is just like the individual task in a sequence. So first the setup, configure, execute, check. And instead of running it, I think it's the best place to just show again like the Perl aspect and underline that. Like you can write a single task, let's call it converge, that just iterates over several tasks and runs them, all of them in a for loop. So at this point, you can also like read a list of tasks from any configuration you prefer, or it can come from external systems, as we will see shortly in the next section. That's where it becomes really flexible and also still providing basically a single button management system, right? So this is what we covered already. So there was a lot that was like about the use cases and some of the patterns and anti-patterns, but we saw like local task, remote task, managing the targets and overriding them, define host groups, execute commands, manage files. Those are the most important ones. Trigger some actions on changes, privilege escalation, and then also how to use the documentation. That's like as a maintainer, I like to underline. We wrote a lot, like often there could be an answer to find, and it's the best to just open them and search for the topics you are interested in. And then of course, in the general Perl spirit, we could just like split it into modules and also call some other task in a programmatic way. So that already gives us a lot of flexibility, which is probably like very good for getting started, because I find these are one of the most common use cases. And here we can stop for some questions. Yes, please.
I have a question that is beyond a bit beyond the scope of what you've shown. And so I've been using Ansible quite deeply for several years. So there is a feature I would like to ask you about. One thing I use pretty heavily are per host variables. So in the way you can actually specify a list of parameters or variables or information per each host. And also this is a very not well-known feature of Ansible, you can actually create groups on the basis of these variables dynamically. Is this something that can be done with Rax as well?
The short answer is yes, and maybe since we are also getting a bit time limited, let's just go to the next section for the more advanced use cases.
Okay.
Some of it, like being data-driven, is mentioned there. So this is like the section about how to grow from here, from the basics of the initial setup. For example, there is some built-in template support. Probably not all of the hosts should have the exact same configuration files, but like slight local variations are possible. So you can just use any templating engine from cPen. There's some limited support built in for simple use cases, but I really do recommend to just like rely on solutions who are already doing this much better. We don't want to create yet another templating engine. And then I think this is where it gets interesting for your questions, like various data-driven approaches are possible. You could get the list of hosts and groups, basically what Ansible calls inventory. You can use some of the built-in modules for various formats like ini, YAML, XML, just run a command and parse the output, or even contact the database. Or you can use any external API. So if you have a central inventory system, it's just Perl. You can ask it via the API and like pass it on to Rex as data. Part of it is like a built-in concept, is the configuration management database. So there's a built-in YAML-based solution, but there are like other modules on cPen in the Rex CMDB namespace. For example, TOML support is there. Somebody preferred to use that. And by parsing those configuration files essentially as an input, it's possible to create dynamically, for example, one of the host groups, or like based on like, I don't know, amount of memory or location in a data center, you can auto-generate these groups. So that's where, again, I think like being Perl-based is really shining and gives a lot of possibilities. And this is all about like integrating with other systems, even bidirectionally, right? Common use cases to interact with monitoring systems, both for like get the list of hosts from a monitoring system through its API and then use that to drive Rex execution. But also like the last step of a provisioning system based on Rex could be to register the host back into monitoring and start monitoring it. It could also open ways for test-driven infrastructure if you think about it. I create a host, it's not reachable, monitoring has an alert, drives the Rex task to please create this host, and whenever everything is in place, it will switch back to green, and Rex can wait for that and poll for the results, like am I done, am I successful? It's also true for chat systems. ChatOps is like pretty popular in various places. Like you can like use Slack or similar or IRC based systems to trigger execution of Rex commands. And I know a couple of use cases from companies who do it like that. But it's also possible that several tasks are reporting back their execution and their status or end result to a shared channel. That's like, again, any direction is possible because it's just interacting with APIs with your own code. Yes, again, test-driven infrastructure, I already hinted it before. Like there are also family of Rex test modules. So it's possible to check for assertions like, is this package installed? Is this file present? Does it have a specific content and so on? And Rex provisions a new virtual machine, connects to it over SSH, executes a task and checks the result. So you can do even test-driven development with it. That's what I call test-driven infrastructure in this context, on top of the monitoring-based approach. There's even a RSpec-based third-party module on cpan. It's a bit older. I haven't used it, but I know there were contributions for like other more popular description languages for testing. And in larger environments, it is also possible to use something like a pool style or a hybrid management. As hinted before, if you have a single task to manage everything, it becomes a matter of a cron job, doing a git pull from a central description, and then just run this single task to manage everything locally. That's like implementing a pool-based model. Or especially in larger environments, it becomes interesting to handle retries and like in general when encountering error during management, because if you think about it, I don't know, you have 400 hosts, some of them would be down or unreachable at the time of running something centralized. Sorry. So there are like job queues available again on cpan, Minion or German are like pretty popular ones, and you can seamlessly integrate with any of them. And also, last but not least, there are like some built-in support for task transactions. So pretty much like what you get used to in databases, you can try to run a task, and if there are any errors, run some other steps to return to another previous state, right? So you can do the reverse. For example, for decommissioning services, like we don't need cronid anymore, you could define something like this, like a destroy task, and it could be the default transaction fallback for failures. Like I tried to do it, but let's just come back to null state. And this is the last slide. I just put a lot of links about our channels, about Rex, also about myself, if you wish to contact me and have further questions. And I'm not hiring, but you can hire me. I do offer professional services around Rex as well, but not just Rex. Please check my homepage or LinkedIn page. And there's even a direct booking link, especially for like open source officers. So I do provide various channels, and I try to be present in whatever you prefer. That's all for me today. Maybe we still have some questions, but we are right on time. I'm happy to stay either as part of the talk or later on the hallway track I can answer stuff.
My question is about dependencies. How do you handle dependencies at task level? And maybe, if possible, at service levels?
Yeah, so task dependencies is a very interesting question and also an important part of any larger solution in my experience. And since there are different needs, and there are also different built-in concepts for that. What we saw today is like use a run task built-in to run other tasks. So that's one way. There's a similar one called do task, and that is like, let's say, a bit older interface. And it is the difference between them is we can pass parameters and execute task on a different host that is currently in scope with run task. Do task just takes the task as it is and execute it. So it's a slight difference, but these are the two approaches there. On top of that, there's a built-in called needs to define inside the tasks some dependencies, like this task needs some other task, even from another namespace possibly. But otherwise, please execute that task in the exact same context. So the same connection, same server, same parameters. So that's like also good for chaining tasks. There's also a built-in concept called batches, which is really just like a list of tasks to run. So it's less about dependencies, but more like sequence of operations. And what I would say, last but not least, you can just try to interact with all the underlying objects and like create your own if you need something really advanced. So you could invent your own dependency management. For example, you have to execute one task first on one machine and then go to other 3 machines, execute in parallel another task, and then come back again, continue with something else. So there are some workflow management modules on cPan that could be integrated into this if it's a need, but there's no built-in features for that yet, apart from like run parallel. I think that's all the things around dependencies, yes. And as you could see, you could drive it from outside description. It could be data-driven, so you can describe this sequence of operations in a comfortable style or config style, and you can just like process it and drive Rex tasks from Perl. All right, I think what I would also like to add before any other questions is like, I'm very happy to show some more of the live demo part to you. I also have like some other cases that might be interesting for you, like event-driven management and using these job queues I mentioned. So I'm very happy to give you a demo, and sorry that it didn't work fully in all cases during the talk.